As we study the equation of lines, we also have to study what will make lines parallel or perpendicular. Your essential question is, how do I identify parallel and perpendicular lines and their equations? Learning intention. I'm learning to identify lines that are parallel and perpendicular by their slopes. You've got 3 warm-up questions. Pause the video and do those questions now. Well, I do hope you tried. On the first one, we start off with the distributive property. We have 2 times 2x would give me 4x, minus 2 times 5 is 10, is equal to 4x plus 8. When I subtract 4x from both sides, I have the statement negative 10 is equal to 8. Is that correct? Is negative 10 ever equal to 8? No. So that tells me that there is no solution. Okay, on the next one, I also have to start with the distributive property. 6x minus 9 is equal to 3 times 2x is 6x, 3 times negative 3 is negative 9. What do you notice? Well, you notice that both sides of the equal sign are exactly the same. Where this never makes sense, this always makes sense. So this is an infinite number of solutions. And finally, we're looking at x squared. But before we can solve, what do we have to do? We have to isolate the x squared terms. So I start by subtracting 5 from both sides. Two x squared is equal to 32. Is my x squared term isolated? No. Now I have to divide by 2. X squared is equal to 16. What is the opposite of squaring? Taking the square root. So x is equal to, what is the square root of 16? Positive 4 is one of the two. Negative 4 is the other. So x is equal to a positive or a negative 4. That last one is to bring up the fact that all your square roots will have 2 square roots. One will be the positive and one will be the negative. This takes us into our definitions. Okay, parallel lines are blank lines that do not intersect. Think about it. They are coplanar. If you do not state that they are coplanar, you could have this kind of situation where one's above the other. They don't intersect, but neither are they parallel. Okay, perpendicular lines. Perpendicular lines are lines that intersect to form What kind of angles? Right angles. Or in other words, those 90-degree angles. The slopes of perpendicular lines are, this is one you might not know, opposite, reciprocals. What are opposite reciprocals? I'll give you two examples. If I had 2, the reciprocal of 2 is 1/2. 2 is positive, I need the opposite, so it would have to be a negative 1/2. 2 times 1/2 gives me 1. Positive times negative gives me a negative. So think about when you graph perpendicular lines. One has to be positive and one has to be negative, or they will not ever come together at a 90-degree angle. So what about negative 4/3 and, well, this one's negative, so the second one has to be positive. The reciprocal of 4/3 is 3/4. That gives you 2 examples. There's plenty. If you need to look at more, Google it, and they'll show you opposite reciprocals. Now, skew lines are lines that are not what? To be parallel, they're coplanar. To be skew, they are not coplanar. And do not intersect. So those are the 3 definitions you need to know. And the important thing about perpendicular is that their slopes are opposite reciprocals. We will be using that as we look at them and as we develop the equations. So we're looking at a box. We're going to identify 3 things. We need lines that are parallel to segment YZ. Here is YZ. What would be parallel? Well, if you said WX, you would be right. Are there any other segments? What about TS? TS would be parallel. This top plane includes WX and YZ. This plane contains YZ and ST. There is one more that would be considered parallel. It's the other side of the box, other corner of that box, which is UW. What about perpendicular? And we're looking at WU this time. Perpendicular means at a 90 degrees. Of course, the first one is going to be WZ. What about WX? Okay, so those are on this top plane. What about on the bottom plane? Do we not have the same thing happening again? Where if we use U for the corner, it would be TU, segment TU. And finally, that last segment will be over here. segment UV. Okay, now skew to ST or SV. So if we're looking at something that is skew, it has to be going the other way so that it will not intersect. We cannot draw a plane at a diagonal between. So that would be YZ, segment YZ. And the other segment would be up here, it would be WX. So those two segments would be considered Q segments. If I tried to use ZW, I could put a plane at an angle in between and they would be coplanar and they would be parallel. So that does not work. Okay, so looking at this, find the slopes of the lines and identify them as parallel, perpendicular, or neither. So on the first one, we're going to find the slopes and prove that the lines are perpendicular. So if I give this line the name of L and this line the name of M, I can find the slope of line L by finding the intersection of two of the grids. It would be at 1 and then down here at 1, -3. 0, 1, and then 1, 0, then 1, -3. So I'm going to go down 1, 2, 3, 4, and go right 1. So it's -4 over 1, which is simply -4. What about the other one? Well, it's positive, so I know at least that much works. I've got to find where I go through the corner of a box. I go through here, and then I go through up here again. So this is up 1, right 1, 2, 3, 4. So my slope for M is up 1 and right 4. So the slopes are opposite reciprocals. So that means that they are perpendicular. Okay, what about parallel? Parallel means that we are looking for the same slope. So I need to identify my lines again. I'm going to call this line P and this line S. So for my slope for P, I notice that both of them are positive. I'm going to look for points where they intersect the corner of a box. Here's one, and as I go up through here, here's the second one. So I'm going to go up 1, 2, right 1, 2, 3. So my slope is 2 over 3. What about for S? Once again, I've got to find where that intersects. Here's one spot. Here's another spot. I go up 1, 2. I go right 1, 2, 3. So that is also 2 over 3. The slopes are the same. If they're the same, that means you've got parallel lines. For the last one, are they parallel? Now you can tell that by looking. Are they perpendicular? It really doesn't look like that, but you've got to prove it. So to prove it, you've got to find both slopes. So I'm going to name these two. I'm going to call one A and one B. So for the slope for A, I have to find the intersection of two boxes. So if I'm looking right here, looks like the intersection. I come on down, right here looks like another intersection. I go down 1, 2, I go right 1. So that is negative 2 over 1, which gives me negative 2. Okay, for the B, it's a positive, and as I'm looking, I'm going to find where it intersects. It intersects here, it goes up 1, 2, and intersects here. So it goes up more than 2. You're going up 1, 2, 3, 4, right 2. Which is a slope of 2. If you notice, I didn't catch the first corner. I could have used that, but as long as you're catching corners, you can always do the math, simplify the fraction, and find that slope. So, how do you know when you're successful? You know you're successful when you can identify lines as parallel, perpendicular, or neither. So, if we want to condense this, parallel lines. Means we have the same slope. Perpendicular lines. The slopes are opposite, reciprocals. And that's how you know whether you have parallel or perpendicular lines, or neither. Because if they're not the same or opposite reciprocals, then they are neither.